we're going to finish 16.4 with the last example of number 3. And it talks about a satellite that's traveling the Earth with an orbit that's approximately 1,800 kilometers above the surface of the Earth. And it tells us it takes 2.5 hours to make an orbit. So if you think about this, here's our Earth, and up here is the satellite. And so if we know that the satellite is 1,800 kilometers, that doesn't really give us the full radius. So what we need to know, which isn't given to you or isn't written down, is you need to know the radius of the Earth. And the radius of the Earth is 6,400 kilometers, or approximately that. So what we have here to find the radius is that we have to take 1,800 plus 6,400, and that will give us the actual radius, which is 8,200. So now that we know that, it's asking us to approximate the linear speed of the satellite in kilometers per hour. So one thing that we also want to know is that one orbit, that's one full time around. So think about what that is in degrees, because that's important. It's 360 degrees, but it is also then 2 pi radians to go all the way around. So then if we want to know the linear speed, we'll use the formula velocity equals arc length over time, but we need to know the arc length, which is the circumference, and we calculate that by arc length equals radius times the angle. So that's going to be 8,200 times 2 pi. And again, that's the circumference around with that orbit. So now what we can do is we can take this, plug it in here, and then the time, it says it took 2.5. So what we're going to do is we're going to plug it into our calculators. That gives us 6,560 pi, which is approximately 20,609. And that's kilometers per hour. So that's the linear speed that the satellite's taking. And what part B is asking for is the distance the satellite travels in 3.5. So if you think about it, it went it goes one full orbit in 2.5 hours. So it's asking how long will it be in 3.5. So what we're going to do there is, again, we're going to use the formula arc length, that will find the distance around, times velocity times time. So what that's going to be is, we know the velocity. That's 20,609 times 3.5, which is 72,132 kilometers.